Alrighty, welcome back. We are now going to get into section 2.4 for pre-calculus, and this is all about complex numbers. So which hopefully you have a little bit of recollection about this, but if not, this will hopefully get you caught up. So the first thing we got to do when we're talking about complex numbers is define what an imaginary unit is. So our imaginary unit is called I. And where did that come from? And it actually came from mathematicians trying to solve this quadratic equation. So x squared plus 1 equals 0. And if you try to solve that and find real numbers that make that work, it's not going to happen. So it will not have any real solutions. So to overcome that, mathematicians created I, which is defined by I equals the square root of -1. And so when you square I, that gets rid of the square root, and so I squared should equal -1. So that's the foundational definition for I. Now, we can treat I just like another variable in most cases. Now, in other cases, we're going to want to break that down. So we're going to see when we have to do those different techniques through this section. So as far as making it complex, then we have to do a little bit more than just having an imaginary component. So when we add real numbers to real multiples of I, we obtain this, the set of complex numbers. So let's get more technical with the definition here. So let A and B be real numbers. So the number a plus bi is a complex number written in standard form. So you can see that the fully real part is first, and then the real with the imaginary part is second. That's always the way it has to look if it's going to be in standard form. So the real number a is the real part, the number bi, where b is a real number, is the imaginary part of the complex number. When b is equal to 0, well, 0 times anything is 0, so then you will have a real number because all that'll be left is just a. But when b is not equal to 0, the number a plus bi is the imaginary number. So a number of the form bi where b is not equal to 0 is a pure imaginary number. So again, just some special terminologies in there, but nothing too drastic. Big thing is just the order of how you should write it, really. So standard form. All right, so the first set of problems are just going to get you used to writing numbers in standard form. So when we have something that looks like this, how do we rewrite it? Well, again, we don't like negatives underneath the square root, so we want to get rid of that. But let's do this really deliberate just to make sure you understand. So the first thing you're going to want to do is break apart this into two square roots. So the first square root is going to be the number piece, so the square root of 9, and the second is going to be that negative sign, which we can just say it's a -1. Because when we multiply this back together, we get back to our original. And that's always your check. As long as you've separated it correctly and multiply it back, you should get back to your original statement. So this is equivalent. But now we can do two things. We know the square root of 9 is 3, and now we know that the square root of -1 is I. And now we're done. So it's a very quick process as long as you realize that you have to pull that negative out and treat it separately. That's your I, the square root of that negative. So we can do the same idea here. So we can split it first of all into the positive 0.16 square rooted, and then our square root of -1. And now we got our answer. So 0.4i. All right, and let's try one more. So we got 2 minus square root of 27, square root of -1. Now the square root of 27, we've got to be a little bit careful about. That's not a perfect square. So we have to separate it so that way it's simplified down. So hopefully you remember this, but if not, so we can split apart the 27 into a perfect square piece and a not perfect square piece. So the perfect square piece is 9. That's the largest one that we could get out of 27. And then we got the 3. So we would do 2 minus the 3 square root of 3, and then we got the I. Now, this is an acceptable way to write it, but if you're at all sloppy, and sometimes people are sloppy because they'll extend this square root too far, you want to be careful to avoid that mistake, because then it means something else if the I is underneath the square root symbol. So to avoid that, what mathematicians like to do is they like to swap that square root with the I. So it would look something like this. 2 minus 3I square root of 3. And now there's no problems. The I is safely away from the square root and not pulled underneath by accident. So this would be the better way when you have that square root as part of that problem. So, okay, so that was a quick little warm-up for this. I think we might be able to squeeze in just a little bit more. We're only 6 minutes in here. Let's go a little further, right? So adding and subtracting and multiplying. Now we are leaving out division momentarily, so we are going to come back to that. But these three we should be able to treat pretty nicely as long as we realize that I is just like another variable. Now we will want to use that I squared equals -1 as necessary. So that way we just get it more simplified. And we'll see where that might happen. All right, so let's take a look here. So we got 5 plus I plus 6 minus 2I. Everything's addition. We got subtraction in here too. But we can drop all of those parentheses out of here. Instead of thinking of this as one complex number and another complex number, just think of it as a big algebraic expression. And you want to combine like terms. So in this case, if we combine our whole numbers and we combine our variable terms, we quickly get 11 minus I. Nothing to it. Same idea when it's subtraction. Now, to be absolutely safe, we could remove the parentheses first and distribute that negative in. So we would get something like that. And now we can combine like terms just like before, but you see that the i's are going to cancel out. So all you're left with is just a real number 4. What about this last one? Well, if we're thinking algebra, we have 2 i's here. We can write that with an exponent. So this should be able to be written as 2I squared. But now we have to apply this I squared equals -1. So we can replace that with a -1 and get an answer of -2. Nice and quick. I think there's just a couple more on the next page, and that will close out this video. So let's take a look. A few more of these. So for this problem here, we have I, but we also have the square root of negative. And now remember, we don't like that. So let's change that into the I format first before we do anything. So we got I times what? Now, if you can start to do this without those extra steps, that's great. But if not, write them in. So remember, the square root of 16 is 4, and the square root of -1 is I. So this would be a 4I. And now we can combine our i's with an exponent. And just like on the previous problem, we can get rid of that that I squared with a -1. And our answer should be -4. More of the same thing. We got negatives under the square root. We've got to take care of those first. So square root of 6 is not a perfect square. So let's put the I in front of it. 2 is not a perfect square, so let's put the I in front of that. And now what? Well, we know the two i's are going to give us an I squared. The square root of 6 and the square root of 2, well, we can just combine those under one square root. So we're going to get I squared square root of 12. And so I squared is -1. So we can just write this as the negative square root of 12. All right, two more, and then we'll close this video out. 6i times 5 minus 2i. Well, we're going to have to distribute. So 6 and 5 is 30, so 30i. And then 6 times the -2 is -12. I and I would be an I squared. All right, well, anytime we have a power of I, we should try to knock it down. So this one we can knock down. So times a -1. And so this will give us 30i plus 12. So are we done? We are not done. Shame on me. Because it's not in the right format. Remember, if it's in standard form, the real piece is first, the imaginary piece is second. So we just kind of flip-flop it, and then we're done. And I got to stop breaking my lead here. So 12 plus 30i. All right. And now let's try this last one. So we got a binomial times another binomial. We know we have to FOIL that out. So let's FOIL. So we're going to have a 3. Our outside is going to be a -2i. Our inside will be a positive 3i. And then our last, I times a -2i should be a -2i squared. All right, let's combine and simplify. We got an I squared, let's get rid of that. We got a couple terms with i's. So it looks like 3 plus I minus the 2 times -1, which is going to be a positive 2. 2 and 3 is 5. So 5 plus I should be your final answer. All right, let's stop there, and we'll pick up more in the next video. See you very soon.